Hi, everyone. I'm Shanisa Cambrick, and thank you for joining us today on the OWASP DevSlop Show. Today, we'll be taking a look at cloud security and IAM from a developer's perspective.
Our guest, David Hendri, will get us back to the basics of IAM. How should it be used in a cloud-native application? How can we ensure our data and infrastructure are well secured?
Whether you're a junior or a senior developer, stay tuned to get a better understanding of cloud security fundamentals.
If you are new here, please make sure to subscribe to our channel and enable your notifications. References to what we'll discuss today will be added to the description box below. I am Stefania Chaplin, and today I'll be co-hosting with Shanessa, Faith, and Nikki.
Hey, everyone. All right, let's get started today. Our guest today is David Hendri. David has over 15 years of experience in delivering enterprise software and leading development teams. Prior to co-founding Solvo, David was one of the first R&D employees at Dome9 Security, leading the development of key features and helping users uphold compliance in the cloud. David is a graduate of MAMRAM, the elite military programming training, and served as an officer in the Intelligence Corps. Welcome, David.
Thank you very much for the introduction, and thank you for having me here today.
Great to have you. So let's get into it here.
Yeah. So here what we are going to talk about today. I'll tell you a little bit about my background and my relation with this topic. We'll discuss the evolution of enterprise systems, what the environment used to look like when it was on-prem, and how it evolved to the cloud environment we know today. What are cloud managed services and why we use them? What is IAM? And I'll tell you a story that illustrates why understanding IAM is so important. We do a live demo to demonstrate how IAM misconfiguration can exploit it and what are some of the risks. And we'll end up with how we can protect ourselves.
Cool.
So, hi everyone, I'm David, the CTO of Solvo. I have 15 years experience in software development. I've been in the cloud security domain for the past 6 years. I got into the cloud security world when I joined as one of the first developers of Dome9 Security, which was later acquired by Checkpoint. After about a year ago, I co-founded Solvo with my partner Shira, who is also a co-chair in OWASP Israel, and I'm the CTO of the company. In Solvo, we are developing tools that helps developers and DevOps to automate cloud security. So how did we get here? So back in the day, you had your data center in your basement. Let's say you needed to launch a new SQL server. Then you needed to go to your nicest IT guy or girl and ask them to add the required resource. Then the investigation begins. What is it for? Why do you need it? Are you really sure you need it? After you pass this phase, then the security questions begin. Who should be able to access it? From what IPs, subnets, what ports? And after you pass the test, then IT can choose where to place this resource. In our example, it would be probably the internal network, and configures the corresponding firewall rules. This process was obviously more time-consuming and limiting, but hands-on and relatively secured. Then, in the beginning of the cloud era, AWS introduced us the VPC, the Virtual Private Cloud, which basically mimics the same model that we just saw, but in the cloud. So VPC is equivalent to your network. Under the VPC, you have the subnets, which are the zones inside the network. You could have a public subnet and a private subnet. And the old firewall rules were replaced by the network ACL and the security groups that together defines the network rules. So if we'll take the example from the previous slide, the SQL Server example, and we try to implement it here, then in this case, when we wanted to launch a new SQL server in our VPC, you went to the nicest ops team guy or girl and asked them to launch a new instance. After a similar investigation, we would probably end up with a new instance in the private subnet with the security groups that limits the sources, the IPs, ports, and whoever can access it. Again, it's time-consuming and limiting, but hands-on and relatively secure. Nowadays, it's completely different. You probably have your awesome CI/CD pipeline that utilize tools like Terraform, CloudFormation, or other infrastructure as code tools to provision infrastructure. So you don't need to go to your friendly ops team and provision infrastructure and ask them to provision infrastructure for you. You can simply do it by yourself. But like Uncle Ben said, with great power comes great responsibility. And we'll get to it later. The cloud environment today looks very different because it's very simple to create your own infrastructure with a lot of freedom and huge variety of options. It usually contains a lot more of micro and nano services that interact with each other than before. These micro and nano services can be a Docker container orchestrated by Kubernetes, or EKS, which is the AWS version of Kubernetes. Or it could be a container running in ECS, which is a AWS proprietary container orchestrator. Or it could be a cloud function that runs your code. In AWS, it's called a Lambda function, and the options are unlimited. I call these compute assets, and these compute assets can use other services. Some of the services are managed services. So what is a managed service? You can see here an example of popular managed services. For example, S3 is a popular blob storage. DynamoDB is a document database. SNS is a notification service. It allows you to implement a PubSub architecture. SQS is a queue service. Usually, SNS and SQS come together, and they serve as a message broker platform, very similar to RabbitMQ. And Kinesis is a stream processing service, which is similar to Kafka. So what is common to all these services? They are fully managed by AWS. It means that you don't need to configure a new environment, instances, security rules, nothing. There are no instances at all, meaning that there are instances, but you don't manage them. You can't even see them in the console. AWS manages the resources behind the scene. So how can you use them? Simply by a native API. You can choose your preferable language, like Python, JavaScript, even PHP, but don't use it. And you use AWS SDK to access these services easily. AWS is adding more and more services all the time. This is a snapshot that I took from the console, and it's a small piece of the long list of services that AWS has. So why do we use managed services? So first, simplified management. You don't need to handle patch management. Setup is very simple, can be one click of a button. Scalability, you don't need to worry about assigning more resources. The service automatically scales to fit your needs. And you pay for what you use. So the cost increases as the system usage increases, which makes sense. In a nutshell, it is meant to save you time and effort as you scale. This is why it is very common to use managed services. Okay, so you created your first managed service, and you can write a simple code that accesses it. But how can you control who exactly can access it? In the world of managed services, network rules are not the answer. It is done using IAM, which is a short for Identity and Access Management. In our cloud environment, we have identities that perform actions, which require permissions. Usually, when we think of an identity, we imagine a human user. But when you think about it, most of the actions performed in your environment are done by application, meaning machines. So, for example, it could be a container accessing an S3 bucket, or a function that reads data from a database. So these applications use roles in order to access a resource. And a role consists of policies, and a policy defines what actions can or cannot be done. So you assign a policy to a role, and then you assign a role to an application. In our case, in this example, it's an EC2 instance, but it could be your container which runs in a Kubernetes cluster, an EKS, or ECS, or a Lambda function. So what exactly is a policy? So an IAM policy is a JSON document. It has a constant value of version, and it has a list of statements. Usually, and I say usually because there are different ways to define a statement, but these are the most common ones. Each statement has an allow field, which can be, the effect field, which can be allow or deny, and an action field, which in this case, it's the get object, S3 get object, which allows you to download objects from an S3 bucket. And the resource that this action can be performed on, in this case, this is an S3 bucket, confidential data. This is the name of the bucket. Note the wildcard in the resource field here. The asterisk means that this permissions allows you to download all the objects inside this bucket. So instead, you could specify a specific object within this bucket, and then of course you will only be able to download this object. Another example here is this policy, which allows you can see that the wildcard appears here in the action field, and it allows all get, list, and put actions on all buckets. There is no limitation on the resource here. So practically, that means that it has full access to this service. So why would someone use a wildcard? It seems so obvious that it shouldn't give that you shouldn't give such permissive permissions. But why using the wildcard is so? It's a common practice because it's easier. It takes time and knowledge for the developers that usually don't have it to understand exactly what are the permissions that are required for a complex application to function properly. And also, no one wants to break the code because of a missing permission.
David, on this slide, I have a question. So I know a little bit about JSON, and in terms of, with the example, if you are doing IAM, do you have any top tips for any developers or anyone in the audience that might be listening about how you configure it? Is it all automatically populated, or what's the kind of best way to do it if you want to do it securely?
So first, it requires a deep knowledge in IAM. It's not there's no simple answer to that, because if it was simple, probably no one use wildcards in the policy. So it requires a deep understanding of the services that you are using and the way to translate the actions that the application does to a specific IAM policy. And we'll get to it later in the
Awesome.
presentation. But that's a great question. So, okay, so we almost got into the fun part, the live demo. But before that, I want to tell you a real life example that shows why what we are talking about is so important. Capital One is a big financial corporation that in July 2019, they reported a breach. The breach caused sensitive data of 100 million users to leak. The cause of the incident was a misconfigured web server with an overly permissive permissions. A smart hacker exploited a vulnerability in the web server that allows her to run commands on it. And the web server was an AWS EC2 instance with an assigned role. The hacker ran a command and retrieved the instance credentials, and by that allowing her to use the assigned IAM role outside of the instance. And this IAM role had an overly permissive policy that allowed access to all S3 buckets. So the hacker scanned all the S3 buckets and retrieved whatever sensitive data she wanted from that AWS account. So potentially, if the role had the minimal permissions it needed, even if the hacker committed the breach, the damage wouldn't have been so massive. It is a common concept in security that security is like an onion, and each layer has its security controls. So in this case, a minor breach in the first layer left the entire organization compromised. Okay, so before we move to the live demo, where I'll show you how an overly permissive IAM role can be taken advantage of and how we can fix it. Do we have any questions from the panel?
There's one question. I think it's a comment/question. Are you assigning the policy that you were talking about earlier, the S3 bucket policy? Is that being assigned to a user or an instance?
To a role, and a role is assigned to an instance. So the policy is part of the role, and the role is assigned to an instance. And this is how the instance gets its ability to perform actions on behalf of that role.
Got it. Thanks.
And this is what we are actually going to do in the demo. So let me set up my environment. Okay. So for the live demo, I'll be using this DVSA project, which is an awesome OWASP project made by Tal Melamed. So if you are here, thank you. This project simulates an e-commerce website. The purpose of this project is to practice cloud security principles. We are going to use this project to exploit a vulnerability in the application and take advantage of an overly permissive IAM role. After that, I will show you how to configure, how the configuration could be set up differently and dramatically limit the vulnerability. So let's start. So this is the application. It simulates an online video game store. So I can select a video game, add it to cart, and check it out. And after a few steps, eventually I'll get an email confirmation with a confirmation number and a link to the receipt file. The receipt file looks like this. It's simple text file. So this is the flow when you order a video game. Now let's say I'm the hacker and I ordered a video game, and I received this email. So let's explore what can I do. So first, let's examine what this link addressing to. So let's copy the link address. And I can see that the link is addressing an S3 bucket. This is the name of the bucket. And here it is the path inside the bucket, the path of the object. So now let's move to the terminal and let's try to use, I'll be using AWS CLI to run commands against this bucket. So the first command I'll be using is this list objects command on the same bucket. And I can see that the bucket is misconfigured, and it allows me to list the items inside the bucket. So I can access not just the receipt file that for the game that I just ordered, but I can see all the receipts of other users inside this bucket. Let's see what else can I see. Now I use this command called get bucket notification configuration, and when I get here is the
David.
Yeah.
Do you mind increasing the font a little? Restraining.
Okay, sure.
Or maybe I'm the one who's training.
No problem. Just a second.
Command plus. Yeah.
It's better.
Yeah.
Now
Yeah, better.
everyone can see.
Much better.
Yeah. So now
Thank
I need
you.
to start all over. Okay. So so this command, what it allows me to get the events that are associated with this bucket. I can see that there is an event that is triggered when an object is created, an object with the suffix, with the raw suffix, and it triggers a Lambda function. Okay, so how can I take advantage of it? Now let's try another thing. So I know once a file is, an object is created in this bucket, a Lambda function is being invoked. So now I'll try to use this command. This command creates an object inside the bucket. This is the path of the object. And as you can see, it ends with, it has the raw extension because I want to trigger the function, but it's not an innocent file name because I added here a shell command. This is the call command. And what it does, it accesses an endpoint that I previously created and sends the data to this endpoint. So now I'll run this command. I can see that I succeeded to upload the file. And I'll go to the hacker account. The endpoint I created eventually integrated with the SQS, which is a queue service. And all the requests are sent to this queue as a message. And I extract specifically the data field. So now if I poll for messages, I can see that I got a new message. And it has the hello world with the text. Yeah.
But David, you're the hacker, right? So you still do not have access to the AWS console, or am I mistaken? How did you get access?
This is my AWS, the hacker AWS console. The hacker created an endpoint that receives data from the injected command that was executed inside the Lambda. So this is the hacker's account, and what I did is running a command inside the Lambda function of the online shop application that sends hello world to my account.
Got you.
Okay?
Yeah.
So,
thank you.
Great. So I now I have a way to execute a command inside this Lambda. So what else can I do? So the next thing I can try to do, again, I'm using the curl command, but this time I'm sending the environment variables of that Lambda to my endpoint. So I'll run this command. Okay, and now I'll go back to the hacker account and see if I got a new message. Okay. And I got this message. This message is encoded in base 64. And this should contain the environment variables that are defined in the Lambda function. So let me decode it and share it with you. Okay, so after I decoded it, this is what I received. I can see here a list of environment variables. Part of them are using for the runtime. Here I can see that is a Python function.
Can you zoom in a little bit on this, please?
Yeah, sorry.
No worries. It's a shame because these glasses aren't even real. They're blue light glasses, but I still can't see.
And for those that are familiar with the EC2 metadata service, this is very similar, just the Lambda metadata service, or the environmental variables that power the Lambda function.
Makes sense.
So it needs to know what it's doing, and it knows it through environmental variables. It's very similar to what you'd see in the metadata service.
Exactly. So what we see here, in addition to the runtime and other environment variables, what is important for the hacker is these environment variables. This defines the session of the Lambda. This is basically the temporary credentials that allows the Lambda to use the permissions that are assigned to the role. And by the way, for the bad guys that are watching us, this is an obsolete data. You can try to use it, but it won't help you. Okay, so what I'll do next, I'll configure this credentials in my machine and try to use the session that is the Lambda session, but from my machine. So let me do it now. So I'm configuring a profile in my machine that contains the same credentials.
Are we going to like attempt a man-in-the-middle attack with that?
It's not exactly it's similar, but what I'm trying to do is taking use the same session that was created for the Lambda, and by that using the permissions that were assigned to the role.
Mm-hmm.
So I'm hijacking the session. So I'm defining the permissions, okay. And now, let's see if I did it right. So I created a profile which is called DVSA, and I use this command. This command using STS. STS is the token service, and the token service allows me to retrieve the identity that is attached to these credentials. So I can see that now the identity is the role of the Lambda function. So now I can perform actions on behalf of this role. But before I'll do that, I want to go back to the application and show you the flow in the application. So I'll switch hats and now will be the developer that created the application. And I'll go back to there. Now it's the application account, and this is the Lambda that we just hacked. As we already know, this is a Python Lambda function. And what this Lambda does, this is the flow of the code. So first, it reads an SSM parameter, which is SSM. It's a centralized configuration service that allows you to store parameters. So it has an orders table parameter that contains the name of the table that we'll later query. Any question? Okay.
Yeah, quick question, just because there's a few in the chat asking about it. The keys that you just configured on the CLI earlier, those were access keys, correct?
Exactly. Mm-hmm.
And you're going to use the session STS service to get a valid token with those access keys, correct?
These access keys are the token that allows me to perform the action. STS, right. The action that I did using STS is just to show you that now the credentials I have are using this role. This is the role that is assigned to the Lambda.
Right. And as far as I am aware, there's no way that access keys need to be manually revoked. They don't time out. There's no expiration on AWS access keys, correct?
These access keys are temporary credentials. They have an expiration time. I think usually it's a matter of hours.
Okay.
And when you manually create credentials, then you can decide what will be the expiration time of the credentials. But because I hijacked the credentials of the Lambda function, then these credentials have a lifespan of a few hours.
Okay, so that's the question: is what's the lifespan of the credentials? Got it.
Yeah, a few hours. That's why I shared the credentials with all you guys.
So they're not static keys; they're temporary keys that the Lambda function is used that are configured for some period of time that you arbitrarily set.
Yeah, this is a legit question because there are two types of credentials. There are API keys that are long-lived and they can be revoked manually. So you need to revoke them. But there are temporary credentials that has an expiration time. So you don't need to revoke them because they have a specific lifespan.
And can we see that expiration time in the environmental variables that you pulled up, or those are not present?
When the credentials, when you create the credential, you set the expiration time. I'm not familiar with a way to extract the expiration time of credentials.
Okay. So the attacker is just going to try it out.
Yeah.
Yeah. Okay.
That's why I need to be quick. Okay. So we're back to the Lambda function that generates the receipt file, and we're talking about the flow of this Lambda function. So I talked about the SSM parameter that contains the name of the table. Then it reads an object from an S3 bucket, which is the raw file that we just created. So it reads the raw file. It reads an item from a DynamoDB table. It combines the two and generates the receipt file that eventually we get in the email confirmation. So it generates the text file and save it in the S3 bucket. And eventually, it sends an email using SES, which is the email service. And this is the flow. So if I go back to the function and let's see what is the role that is assigned to this function. So I'll go to the configuration, and here I can see the assigned role. Okay, so this role has consists of two policies. One is AWS Managed Policy, which is a predefined policy that AWS created. So every AWS account consists of a long list of AWS Managed Policies. And AWS offers developers to use these predefined policies to ease the use of IAM. The developer chose to use a DynamoDB read-only access policy, which makes sense as we're reading the data from a DynamoDB table. But if we'll open this policy and we'll see what are the permissions, then we can see that there are not only permissions or broad permissions to DynamoDB, but also permissions to other services. Some of them are relatively sensitive, like IAM, KMS. KMS is the key management system. It's a popular service to handle encryption and decryption. So these are relatively sensitive services. The other policy is an inline policy. An inline policy means that this is a custom policy the developer created. And the developer, as we saw in the presentation, use wildcards because it's easier and it requires time and knowledge to craft the specific actions. So practically this policy means that it grants full access to these services, and there's no limitation on the resource. So this is the policy that assigned to the role, and this is the action that the functions allows to perform. So let's see how we can take advantage of this role. So I'll go back to the console. And now I'm the malicious hacker. And I'm trying to explore what permissions I have. So first I can try to describe all SSM parameters. So this command lists all parameters in this account. I can see the orders table that probably contains the name of the orders table. But in addition, I can see here the MySQL connection string, which might be sensitive, Salesforce API key. So I can see here other keys that contains sensitive data. So now I can use the get parameter command and fetch the value of the Salesforce API key. I need a decryption, but I have full access, so I can decrypt it and see the value of the Salesforce API key. So now I can use this API key and explore what sensitive data you have on your customers in Salesforce.
Can you just describe SSM a little bit? Like, yes. What is SSM and what are you querying in SSM?
Sure. So SSM is a popular configuration service. Usually, the idea behind SSM is to allow you to have a centralized configuration for your application and control what components can read each part or parts of the configuration. So usually you'll see there connection strings, API keys, because SSM is integrated with KMS, which allows it to encrypt data. So it allows you to, instead of embedding in your configuration file sensitive data, then you can use SSM to to store it in a more secured way. But again, if you configured your policies with overly permissive permissions, then it not necessarily protects you from getting this sensitive data.
So you're essentially using SSM Secrets Manager. That's what you're querying right now to try to find more secrets that are stored for the use of this application so that you can further your...
Exactly, because the application is only using the this parameter, which is a simple string. It's not a sensitive data. It's not encrypted, but because I have permission to all other parameters, I can also read parameters that are defined as a secure string, which is an encrypted parameter, and this is how I got to the Salesforce API key and got its value. Does that answers your question?
Yep.
Great.
Thank you.
Okay, so the next thing I'll try is to exploit the DynamoDB permissions. So I can list the tables, and I remind you that the DynamoDB permissions came from the AWS Managed Policy. This is something that the developer didn't create it by his own. So this permission allows me to list all the tables, and now I can try and scan the orders table and see what other orders were created in the system. So that these are not only my orders, but it's the entire orders in the entire application.
So David, quick question.
Yeah.
So if we were to look through the logs, are we seeing this activity as you, the attacker, or as you, as the developer who's taking over somebody's session?
It depends. Like when you say logs, you mean CloudWatch logs? I guess so.
Yes.
So CloudWatch logs is the and CloudTrail are the services that log any activity in the account. But usually, CloudWatch and CloudTrail log any management activity and not data-driven activity. Meaning scan of a table or fetching an item from a table is not necessarily, or these specific actions are not logged in AWS, and it will be very hard to identify a bridge that's using these actions. But if I'll try to delete or create new tables, then these actions are these actions logged in CloudTrail, and then intrusion detection systems and anomaly detection system might identify the anomaly. Does that answer your question?
Yes, thank you.
Great. Okay, and similarly, I can try now and use the S3 list buckets operation and explore what other buckets there are in this account, similarly to what the hacker did for Capital One. And now I can try and list the items inside each bucket and search for sensitive data. Next, I'll use. So next, I'll try to use the send email permission. And here, what I'm trying to do is send an email, but instead of sending from the do not reply generic email address, I'm faking an email from Richard that tells Jared, please execute the money transfer. So I can generate emails that are, or to impersonate a different user in the organization. Usually in SES, you approve your domain, your organizational domain, and this allows you to send emails using using your domain. And usually the entire domain is approved. So once the entire domain is approved, you can generate whatever email addresses under this domain. So in this example, I'm generating a fake email from the CEO, and this can be potentially very risky. The last exploit I'll use is the assume role. Again, here I'm using the STS, the token service, and the command, the action is assume role. Assume role is an action that allows you to get temporary credentials that allows you to use the policy that is assigned to a role. So in this example, I'm assuming the administrator role, and in this way, I will get permission to use this role or to perform actions on behalf of this role. So basically what a hacker will do is simply enumerate on a different names or popular names of roles, administrator, admin, DevOps, developer, whatever role, whatever popular name came up to his head. And here in this account, I have the administrator role. And as you can see, I succeeded and got a session to the administrator role. So basically now I have an admin privilege on this account. Okay.
The attacker is now God.
Exactly. That's it. Okay. So recap on what we did so far. So we took advantage of a misconfigured S3 bucket in order to inject a command to a vulnerable code running a Lambda function. This code allowed us to hijack the Lambda function session, which allows us to use an overly permissive IAM role that was assigned to this Lambda. This overly permissive role allowed us to collect sensitive data and to send emails on behalf of other users, and eventually to gain an admin permissions. So the question is, how can we reduce the risks?
Go back to enterprise security.
Yeah, build my own data center in my basement. Probably not. So first, don't make your S3 buckets public. And if you need to expose them to the public internet, then do it with caution. When you create a public bucket, so first AWS has these red alerts, and basically when you create a bucket by default, you have this configuration on, which blocks all public access. So even if you define a policy that allows public access, this will block it. So make sure you have this on, and really take caution when you expose your buckets to the public internet.
If I can just add to this, when I was learning AWS, I remember, because when I started and I was doing the S3, because that's the first module, all the buckets were public by default. So anything that you opened, anyone with the URL could find. And then what with kind of a couple of the hacks that happened in the last couple of years, now it's by public, and then especially with a lot of red. So I really like that AWS is continuing to add, because this is such a easy vector to kind of misconfigure, and then all of a sudden you can get in a lot of trouble.
Yeah, that's a great comment. Really, it's very it's happening all the time. Really, it happens all the time.
However, I think we should also bear in mind that there's sometimes that a public bucket is necessary, right? If you're if you're, let's say, hosting, I don't know, videos somewhere, it's necessary that that bucket is public. So
first,
context.
so what can there is one thing I can say about this is that you can generate self-signed links that allows you to access a bucket, but in a limited period of time. So you can generate a link and share it, and once the link is expired, you can't use it. So this is one thing. And the second thing is when you expose the bucket to the public internet, so make sure that the policy allows only the specific commands that you want to allow, and don't use wildcards.
Yeah.
Okay. Okay, so now we need to remove all excessive permissions from the role. But how would we know what permissions an application needs in order to operate properly and comply with the least privilege model? You need to have a deep understanding of the behavior of the application, what services it needs to access, what actions it needs to take, and how it translates to an IAM policy. So let's take another look on the flow. So our Lambda is accessing a specific SSN parameter. It reads a specific item from a DynamoDB table, from an S3 bucket. It reads a specific item from a DynamoDB table, from a specific table. And again, it creates a text file in the same bucket. And actually, it deletes the raw file. So I didn't mention here, but it deletes the original file and just creates the new file. And eventually, it sends the email. And the source address of the email is the do not reply address. So let's see how we can improve the policy. So I'll go back to the to the role.
Hey, David, could you just bring up the font just a touch in the web browser? Just to make sure everyone is, sorry.
Sorry, next time I'll make sure that all the fonts are
cool,
big and clear. Okay. So
we need a read, a create, and a delete, right?
Yes, but let's see how it translates to an IAM policy. So first, we know that this STS permission is not needed. We can remove it. It's better like this, because the Lambda function, it doesn't need it doesn't access to STS service. Next, we'll add the permission get a parameter, and now the action is specifically get parameter, the orders table parameter. So you cannot list the entire parameters and try to extract the value of other API keys. You can specifically get this parameter. Next, we allow only get, put, and delete object from this bucket, from this specific bucket. So you can't list other buckets. You can't even list the objects inside this bucket. You can get a specific object by its key. Okay, the next thing is the DynamoDB. So from the all managed read-only policy that we used, we just need the get item permission and the get item from this table. That's it. So we can't scan the entire orders table and see what other orders were made simply just this. And here I add the send email action, but here there is a different way to configure it. We have a condition. IAM has a long list of tags, and there are many options for conditions and keys. In this case, we are adding condition on the from address, and in this way, I'm limiting the ability to send emails from only this email address. So now I can't fake an email from the CEO, from Richard. And okay, and eventually, just one missing piece. This is a basic permission for a Lambda function. Lambda function needs a permission to write logs to CloudWatch logs. So, so this is the way to configure it. It allows it to operate properly. So we need to add put log events action permission and create log group. And basically that's it. That's this is a least privilege policy. So it contains all of the actions that are needed for this function to operate, but there are no other permissions that are not necessary, and there are not any excessive permissions. So this is the minimal permissions that are required for the Lambda function to operate properly. So before we move to the Q&A part, I would be happy to take a couple of minutes to show you how this process can be done using Solvo. Any questions so far regarding this process?
No, it makes sense. I mean, being explicit as possible is obviously, the best way to configure these things in AWS. And I guess, the natural question here is like, if you're building an app from scratch, it's probably pretty easy to, design this explicitly. But if you have like sort of a larger IAM kind of profile role footprint, like how do you even begin this process? What do you do? Just Control F or asterisk and start marching it back? Is there a shortcut? Is there?
I'm not familiar with a shortcut. Again, you need to have a deep understanding of what exactly how the application behaves, and translate this to an IAM policy document. And it's not easy, and it's not that trivial. And this is what we are doing in Solvo. We are helping developers to do this process. So first, this is a Solvo console. We are in the inventory page. We can see the types of compute assets we have in our account. So I'll go to the Lambda page, and here I can see all of my Lambda functions. So I'll go to the send receipt function. And first I can see an information about this asset. And then I have an overview of the security posture of this function. I can see that this function has permission to access 19 AWS services, but only 6 of them are essential for the function to operate properly. Here I can see in the action level, I can see that there are this function needs only 10 actions, and it has 448 excessive actions or permissions to actions that this function doesn't need. So there are over 27% of excessive permissions. The effective permission table allows you to understand, it translates all the wildcards and the multiple policies to a flattened list of actions. So you won't see here any wildcard, you simply see the entire list of actions, and next to each action, you have the source of the action and whether it's essential or not. And also we have insights that tells you how you can improve this permission. So this is more of an educational to help you understand the current status and how you can improve it. But eventually we'll have the get policy suggestion that allows you to get a custom policy that was generated automatically by Solvo, which is very similar to the one we just crafted. And you can see here the specific actions on a specific resource. And you also can see here that the S3 permission was divided into two statements, because the delete and get are executed only on raw files, and the put object is executed on a text file. So basically, it's very similar to the policy that we just created. But again, it was generated automatically by Solvo. So if you are curious, soon we'll be launching our freemium version. So you'll be able to try it by yourself. And also we have our complimentary assessment called the Security Genie. It is available on our website, solvo.cloud. So if you want to get an early access to the product or get the assessment, simply email us to securitygenie@solvo.cloud. And thank you.
Great. So how does Solvo work? You give it a role in your AWS account and it pulls in all of the IAM roles and profiles you have and then does that analysis? Is that how it works?
Yeah, so the integration, so the integration is super easy. You just need to onboard your AWS account. And from that point, Solvo analyze and understand your system behavior and generate the IAM policies that are least privileged for that application.
But what type of permissions do you need?
Solvo needs only read permissions. Specific, it's called security auditor. It's an AWS Managed Policy that allows third parties to access your environment. So it's very not intrusive permission.
Yeah.
So I have a question.
Yeah.
I have a question. I'm one of those people that knows the OWASP top 10, like the security ones. So I was thinking about where this would sit, because there's a couple of areas. So you've got like A6, which is security misconfiguration, which is where this normally goes. But then what you've been talking about is about the IAM and like law of least privileges, which I would put as part of broken access control. So because these don't quite fit, do you think there's going to be, whilst we have the web top 10 and the mobile top 10, do you think there's going to be a cloud security top 10 coming soon? Or do you think we're heading in that direction at least?
I think that eventually we'll have. It is very similar. Maybe the translation of the vulnerability is a bit different, but the concepts are very similar. And as I said earlier, we have the onion approach that you need to apply security controls in each layer in order to improve your overall security posture.
Awesome, thanks.
And can Solvo plug into your CI/CD pipeline some type of way? So, should it identify that there's excessive permissions, maybe you stop a deployment, or how could that potentially work?
Yeah, so the customer can choose whether we have all the data that is available in the console is also available in an open API, and the customer can choose how he wants to integrate Solvo in the CI/CD and fail the build if an excessive permission was created. So yeah.
Thanks.
Cool. I don't see any other questions in the chat.
Nope. I guess we're done.
Yeah, I don't unless we have any other questions here, but no, I mean, I think this is a great topic. You're right, David. This is like the problem in the cloud, right? Like, mispermissioning things, and it's very complicated. If you go into the AWS like IAM guide, I think it's like hundreds and hundreds and hundreds of types of roles and actions and permissions that you can add to each profile. I mean, it is not trivial here. So it's no surprise that things get like sort of confusing and a little bit messed up and can cause big misconfiguration issues. So it's a great discussion. So thank you.
Thank you.
Okay, so before we wrap up, I just want to announce that Shifting Cloud Security Left is our next presentation next week. So as you've seen, maybe if you've attended the show before, we've talked about static analysis tools for IAC like Chekhov, like Fugue, like OPA, and oh, that's not the right advertisement, it's this one, for Shifting Cloud Security Left for next week. So basically, Christophe Tafani-Desrepert did analysis of all these tools and will come and visit us next week to tell us which tool, the pros and cons of each tool. So make sure to come and visit us next week, and follow us on all our social media, whether it's Twitter, LinkedIn, or meetup.com, where you'll see what we have coming up left.
Great. Thank you, everyone. Thank you, David.
Thank you again for having me. It was a pleasure.